Hello students, this video will lead us through the steps that we will follow to create a Lewis dot structure, or really kind of a before and after to show how we create ionic compounds. So we are going to show the combination of lithium and fluorine. Lithium comes in with one valence electron, and we know fluorine has 7, being a halogen. Now we put the plus sign here because we are adding these together, and the plus sign shows that they are separate entities at this point. But we know for an ionic bond to happen, the metal will transfer its electron to the nonmetal. And how perfect. Lithium will give this to fill this empty void for fluorine to satisfy its octet. Now it doesn't matter how you draw your arrow. Truly, truly, truly. You could have drawn more of a straight arrow. You could have gone even kind of curly. As long as you can see, okay, it's starting here and it's going there. Now, what physically have we made? Well, lithium now is charged. And I don't show it has valence electrons because I'm referring to what I started with. Now, we know lithium is 1s2, 2s1, and so once it loses that, there will be electrons. But again, I'm showing the new formation compared to what we started with. However, fluorine now has picked up 1, and so it now has 8. We know in Lewis dot, anything that is charged, we show in brackets with the charge as an exponent or superscript. So these will now electrostatically attract each other, and I no longer have a positive sign. This is one entity. The positive and negative charges should balance or add up to be 0. This entire drawing is what we call the Lewis dot structure for the combination of lithium and fluorine to form the ionic compound. Let's move onward to magnesium and bromine. Magnesium has 2, bromine, being a halogen, 7. And I want to show them as separate entities. Okay, magnesium can give away 1 to fill the octet of bromine. But magnesium has another. Where will it go? It's not just going to partially react to fill it, to get the octet. It's all or nothing. It either gives away the 2 or not. Well, we could come up with many suggestions. However, what will happen is we need another bromine to take that extra. Not all compounds have this beautiful balance of give and take. Often we need more of one of our species. So if this other bromine comes in, and it doesn't matter, you could have written it here, could have written it, just as long as everything is clearly shown. And that electron is going to go there. And so I now will have my magnesium without the 2 valence it started with. It lost 2, so it's positive 2. And now I have 2 bromide ions. Each gained 1. Each is a negative 1. The other way that you could have written the product side of this is magnesium, and then you have 2 of the bromines now with 8 and a negative 1. Again, the charges need to add up to yield 0. So positive 2, negative 1, totals to be 0. Positive 2 and 2 negative 1s will end up being 0. The other thing that you could also yield is the formula that results from combining these. So by reacting these, I know that the formula will require 1 lithium for every 1 fluorine, but here, for every magnesium, I need 2 bromines. So if you're asked to yield the formula. Transition metals. The transition metals, we are not expected to know the charge that a transition metal will form at this point in time, just that it will form a cation because it's a metal. what is given as a Roman numeral is the charge that nickel will take on. So if nickel will form a positive 2, it must be starting with 2 valence. Here I have cobalt. Sorry, we should be proper form with the top and bottom of that. So if cobalt is forming a positive 3, it must be starting with 3. Now, can we go back here? Aluminum, sulfur. Now, sulfur will need 2 to satisfy its octet. So I can take 2 from aluminum. But aluminum has another to give, and it's all or nothing. Okay, so I'll bring in another sulfur. But sulfur also is all or nothing. It's not just going to form a -1. It needs a -2. Okay, so we'll have to bring in another aluminum. So that can happen. We can keep, and then we'll need another sulfur. And so what we'll end up having here are 2 aluminums. Each loses 3, forms a positive 3, and 3 sulfurs. So collectively, positive 6 and a -6, so that would add up to be 0. And then our formula would be Al2S3. So that would be the greatest extent where we would, need to add both the metal and multiple nonmetals to be able to satisfy the give and the take of the electrons. So that is great examples of ionic Lewis dot, and this entire thing would qualify as the Lewis dot structure for the combination of aluminum plus sulfur.